differentiate using the chain rule and substitution. This video has 8 problems in it, including cosine, sine, tan, e, and natural log. So if you want to scroll through and see which one you want to see, you're welcome to do that. The first thing we have is this square root function. And the first thing I'm going to do is use substitution. So I'm going to let u equals 3x squared minus 2. And when I differentiate that, I'm going to differentiate the derivative of u with respect to x is 6x. So that's my inner function. My outer function, I'm going to let be y. My outer function is the square root of u, which also equals u to the 1/2, the rational form. When I differentiate y with respect to u, I get 1/2 u to the negative 1/2. Okay, so the way you're going to do this is you're going to take your derivative of f is going to equal, and what you're going to do is just multiply these two. So you get 6x times 1/2 u to the negative 1/2. Simplifying this, I get 3xu to the negative 1/2. Now, writing this out, this goes in the numerator. That's 3x, and then we have the square root of u, or u to the 1/2. So that's going to be square root of u. My u happens to be 3x squared minus 2. So again, this part right here, let me write it up here, that would just be 3x over u to the 1/2. And then my u happens to be 3x squared minus 2. The next one I have is this one. So the first thing I'm going to do is let u be my inner function, which is x squared minus 4x. And I'm going to let y be my outer function, which is cosine of u then, because I'm going to let this be u. Now, differentiating, we get derivative of u with respect to x equals 2x minus 4, and derivative of y with respect to x, the derivative of cosine is just negative sine of u. Now, we merely get our derivative of x there, g then, by multiplying these two. So that's going to be 2x minus 4 times negative sine of u. And I'm going to bring this negative in front, so I'm going to get negative 2x minus 4 times sine of u. And my u happens to be, I'm going to take out this parentheses here. My u happens to be here. So I'm just going to write x squared minus 4x. And that's your derivative. Okay, the next one we're doing is this one. So I'm going to let u be this part. So my inner function would be u equals x squared plus 5x minus 2. Therefore, my y is just going to be 7e to u, because I'm using that as substitution. Now, the derivative of u with respect to x equals 2x plus 5, and the derivative of y with respect to u equals the same thing, 7e to the u power. Now I merely multiply these two, so I'm going to get my derivative of h is 2x plus 5 times 7e to the u power, and that's going to equal I'm going to go ahead and distribute the 7. 14x plus 35 times e to my u. My u happens to be x squared plus 5x minus 2. The next problem I have is tangent. So I'm going to let u be my inner function, which is 2x plus 3, and my y equal tan of u, my inner function. Now when you take the derivative of u with respect to x, that just equals 2, and the derivative of y with respect to u, derivative of tan is just 1 over cosine squared of u. Again, we're just going to multiply these two together, so you get 2 times 1 over cosine squared of u, which equals 2 over cosine squared, and my u is 2x plus 3. And that is your derivative of y with respect to x. The next one is natural log. So I'm going to let this be my inner function, is u, and my outer function, therefore, would be just ln of y, or ln of u, sorry, ln of u. Now we take the derivative of u with respect to x, that equals 2x minus 3, using simple rules, and my derivative of y with respect to u equals 1 over u. Now what we're going to do is multiply these two, and you're going to get 2x minus 3 times 1 over u, and this is our derivative of p here. And simplifying this, you get 2x minus 3 over my u. My u happens to be x squared minus 3x minus 10. And the next one is this one. So my inner function is going to be 3x plus 2. My outer function is going to be y equals u to the 8th, because we're calling this u. Take the derivative of u with respect to x. That's just going to give us 3. And we're going to take the derivative of y with respect to u. That's going to be 8 u to the 7th. You multiply these two. So that's going to give you 24. And this is for our derivative of d of x. This gives you 24 u to the 7th, and then substitute back into your u. Our u happens to be 3x plus 2 to the 7th. Okay, the next one is sine. So I'm going to let u be my inner function here. And then my outer function would be 4 sine of u. Now we'll take the derivative of u with respect to x. And that's just going to give you x. And then no, that gives you pi, sorry. I knew I did something wrong, pi. Now derivative of y with respect to u is the derivative of sine is just cosine, so that's going to be 4 cosine of u. Now we multiply these two together, so you get derivative of a of x equals pi times 4 cosine of u. And our u happens to be right here, which is pi times x plus 2 I don't like how that looks, so I'm going to go ahead and put the 4 pi cosine of pi x plus 2. Then my last one is this quotient one, which is going to lead into using the quotient property. So my u is going to be this inner function here. U equals 2x cubed minus 5x. Therefore, my y is going to be 3 over u to the 4th. I can write this as 3u to the negative 4. Now, take the derivative of u with respect to x, and we get 6x squared minus 5, and take the derivative of y with respect to u, and you get negative 12u to the negative 5. Now let's multiply this together. Multiply these two. So you get 6x squared to get our derivative of y with respect to x. So you get 6x squared minus 5 times negative 12u to the negative 5. Now simplifying this, I'm going to go ahead and distribute my negative 12. Or not, maybe I'll just put it out front here for now. So we get 6x squared minus 5 over u to the 5th. So this is going to be negative 12, 6x squared minus 5, and my u happens to be this. So that's going to be 2x cubed minus 5x to the 5th. And I'm just going to leave it like that. Thank you. Have a nice day. Bye-bye.